Covalent bonding. The octet rule. Atoms tend towards having a full shell electron configuration. For most atoms, that means having 8 valence electrons, hence the word octet. In covalent bonding, an atom will share electrons in an effort to obtain 8 electrons around it, with a few exceptions as shown below. For example, hydrogen only needs 2, beryllium only needs 4 electrons, and boron only needs 6 electrons. Lewis structures are diagrams that show valence electrons as dots. They are also known as Lewis dot or electron dot diagrams. Note that no electrons are paired until after the 4th one. So let's just see lithium 1 electron, beryllium 2, boron 3, carbon 4. Notice they're not paired up. And then you get over here to nitrogen and you start pairing up the electrons. Then oxygen has 2 pairs there. 2 nonmetals will share electrons to complete their outer shell. Hydrogen and fluorine both need 1 electron to complete their outer shell. So here you have 2 hydrogens, and they join together and they have a shared pair of electrons, right? This blue one is from the blue hydrogen and the green is from the green hydrogen. Obviously the electrons and hydrogen do not have colors. This is just to help you visualize it. Then you have fluorine over here to form F2. They share these electrons right here. So they have a shared pair of electrons between them, and each one now has 8 electrons. A Lewis dot structure will commonly represent the covalent bonds by dashes. As in the examples below, 1 shared pair of electrons is represented by 1 dash. So in the previous slide, we had hydrogen here with the shared pair of electrons. You replace that with a dash. You have the 2 fluorines over here. You replace these 2 electrons with a dash. Now, you keep all the other electrons as dots. A pair of valence electrons that is not shared between atoms is called an unshared pair, also known as a lone pair or a non-bonding pair. So here we go. Here's a lone pair. Here's a lone pair. Actually, all these guys are lone pairs. And over here on the nitrogen.